que cambiar. I'm so pleased to see you all in person. I've been doing lots of talks remotely, and it's not the same. So it's a pleasure to be here in Madrid. And thanks, Juan, for having me, and thanks, Idealista, for sharing your office and your space. So yeah, it's really amazing. The first question I'll have for you today is how many of you are writing compilers or are inventing new monad or type systems? Okay, I cannot. Okay, one person. Lovely, lovely. You have this one. Okay. And who's working with things like JSONs, exposing APIs, maybe talking to Kafka, doing some metrics. All right, lovely. So I think that this talk might help you, and you might actually enjoy this, because today I'm gonna be talking about things like how can we have all the robustness that comes with the functional programming, but solve industry approaches. So solve industry problems, solve things that that this manager comes to you and asks you to, hey, can you expose this API, consume this JSON, maybe add something to Prometheus, maybe expose some Swagger docs, and this are like really basic stuff. And you're like, your colleague is like, who's using Java, is like, okay, I can do this with Spring Boot and all this magic behind that in like 1 hour or like half an hour. And you're like, okay, but let me read about this new monad or type system, and just let me become a new category theory expert. I'll be there in like 1 month, okay? And in modern world, modern software engineering, we don't have that much time, because we want to move fast. We want to have this fast feedback, and we actually want to focus on the business problems, not on problems with our tools and our ecosystem. So in this talk, I will talk about things like what libraries are there to solve common problems, how they work together. Do they fit nicely together? Or we should rather stay with nice one stack, and migrating between stack is not actually that possible. So is Scala ecosystem ready for all the things that are coming in our world, in our fast and very moving forward world? What can we do? Maybe there are some things that we are missing. Maybe we cannot do all the stuff that we would like to, and we will have to like write some middleware or some integrations by hand, which we don't want to do, because we want to utilize the ecosystem and build from this building blocks that we have. And last but not least, how fast can we write business code? So focus on what we need to do on our validation, and not how to write something to database because something is not working. Okay. So as you can imagine, these are the people who are inventing type systems. They are inventing, they are implementing libraries like Zio, like Cats Effect. These are gods to me. I have just a little knowledge about this stuff, but that's actually me. I want to use this stuff, and I want to have the functional programming in my code base, but not maybe understanding everything about cats in particular, or Zio. I want to use this, but I don't have that much time to or life to waste to become any category theory expert. So I'm just a simple builder. Have 6 years of development experience. Last 3 years I've been working with Scala, and I'm a tech leader at Fintium. We do intraday trading for the large UK banks. So yeah, that's quite fun. And that's what I do daily, and nicely I'm trying to do some pull requests to open source, but only to these parts that I can understand, so not much. And I'm trying to blog and speak and various meetups and conferences. All right. So in today's talk, we will mostly focus on the API layer. In the API layer, we usually want to have things like declarative API. So we want to expose some endpoint that someone can call from the outside world. We want to have some codex serializers, whether you're working with your entities, whether they are JSON entities or they are God please no XML entities. We'll have to serialize them and translate them from this meta description to our domain language. We want to have the type safety that comes with the functional programming. Obviously, we want to check. We want to let the compiler check what's going on, whether we didn't mess up things with our type system. Otherwise, we would be using things like Python or Ruby or things like that. From time to time, we want to add some middleware, whether it is for logging or adding coordinate ID that will be running between your microservices. Maybe you want to do some authorization for your users, check their passwords or cookies or some tokens. And yeah, we want to have this mythical error handling that we can use with the functional approach. Okay, so we don't want to populate exceptions to the outside world. We want to handle everything nicely and gracefully. Some of you might want to use gRPC if you're using that. Some of you might want to use WebSockets. So we'll talk about most of these things today. Okay. So firstly, we'll go through how can we have the API description and whether decoupling your API description from your HTTP server is actually a good idea or not at all. We'll talk about simple HTTP server. We'll serialize and deserialize our entities. We'll also talk about things like docs because we because we don't maintain the YAML files ourselves. We, as some people say, documentation is blessing and liability. It's a blessing for those who read it, but liability for those who have to maintain that. So it would be really nicely and handy if we could have our docs like that from our code. We'll also have a look at how can we test our codes, how can we employ metrics to see what's happening in our system. And we'll also have look at the HTTP client, because from time to time we have to talk to another API, or maybe you're not using asynchronous communication between your services with things like Kafka, but or any other message queue, but you're using asynchronous HTTP calls. All right. So in the Scala ecosystem, we have actually quite a few options. Fortunately, we will not have that much time to talk about all of them, but I think that two most important ones are HTTP4S, that is based on the CATs, as some of you might already know, and Zio HTTP, which is quite a new standard for some microservices. We also have other options like Akka HTTP, Armeria Play, Scalatra, and then OKHTTP as a backend, but we'll mostly focus on first two. Okay, so HTTP for us is a typeful things. That means that all the things share immutable structures. It uses functional programming. Hence, it's built on top of CATs and CATs effects. Everything is monadic, so we favor functional programming and declarative style over the object-oriented way of doing things. It supports streaming because it's based on FS2 library, so you can have WebSockets if you really want. And it's a cross-platform, so it builds natively for Scala, Scala.js, and also Scala native from a few recent versions. Okay, so to have this, all you need to do is to add the simple snippet to your build file. In my case, it's built as BT. The first library indicates which kind of backend we will use. We'll use Blaze, but I'll show you some examples with Ember as well. We'll have HTTP DSL to use our DSL language that comes with HTTP4S, and we also have a CRC as our entity serializer, right? So this talk is mostly based on Blaze and Ember, but there are also other backends if you fancy using them. That's fine, and it does not indicate any changes with the code. So it will you will just have to change the builder, but you have to remember that not all of them comes with the things like HTTP client. Okay, all right. So before we start, we'll have to introduce some kind of domain. Okay, so very simple domain. We'll have a book, and we'll have an author of this book, and we'll have two services. I'm not doing dependency injection. I'm not injecting them through interfaces as we would all do. This is just for the simplification. All right. So in HTTP4S, the server is a function. So wise people would call it slicely. I understand that it's that the request coming will have the response. So it's a function from request to response, which is quite easy to understand. But the thing is that not for every request we might have the response. That's why it's an option. That's why it's wrapped in an option. And obviously, the response might execute or have some side effects. By side effects, we usually mean things like calling another microservice with HTTP client, or talking to the external world through the database, or maybe sending something to Kafka. That's why it's wrapped in the F, which is the monad type for this. So the most important part for the HTTP4S is its DSL, and the DSL allows us to write a set of functions. So it's a partial function. The first part is a tuple. The first part of the tuple is a name of the HTTP verb. The second one is the actual endpoint, and then we have a response. In this case, we are wrapping this in the OK response, which counts with all the things like all the correct HTTP codes, status codes, predefined cookies, and so on. And we are passing the author service that is called get all authors. Okay. Because we are having CRC, we use this fully auto derivation. We don't have to write everything ourselves in terms of decoders. Therefore, I would not be so sure about fully or like automatic derivation with CRC because I've seen a few issues with that. I would prefer to have semi-auto derivation for that serializer. Okay, so let's introduce something more fancy because that kind of endpoint would only be in things like health checks. It was quite simple. So let's introduce two query parameters. The first one will be about author. So because it's a string, we don't have to make any conversion, or we don't want to do the validation. All we have to do is to create the object that will extend this query param decoder method, and will indicate the type and the name of this query parameter. With here, it's going to be a little bit more difficult in this case, because first we will have to create our own implicit to be in the scope. So we will try to convert this integer, because at the end of the day we don't know anything about the year or value that comes with the in the query parameter with our URL. We'll try to map this to a year, and then we again create the object in scope that extends this time optional validating query parameter decoder method with type year, which is our custom type, and the name of year. So how can we use this? In this case, you can see that we try to fetch two parameters. Firstly, we see whether we can fetch author books for this particular author, and then we have this maybe year value that can be a year or might not be a year at all if it fails if it fails validation phase, and that's when we decide whether we want to continue with that or we want to return these books by author that we have fetched before. And we can use extension methods called as JSON that comes from the HTTP Source integration. So it allows us to have this magnificent derivation of our entities. Okay. Once we have our routes, it's a good moment to expose them to the external world, so we can compose them together inside of the all routes complete. That's where we defined. I'm not sure if it's visible on the screen, but yeah, we can compose them together and define or not found. So for any route that will not be found, we can return 404. And we have to build the server itself. So we provide the custom runtime. This one comes from Catch, and we create we define host and port. We define routes, and because this is like it's like a Catch resource, we don't want to close this, and we want this to run forever. Okay. On the previous slides, you were able to see get endpoints, but we can also have other ones. Post, put, whatever you want. Delete is also there. It supports all of the ACP verbs, ACP4S. Yeah, I think it's quite easy to understand, even for a new joiner that comes to the company, to the team, or is new to the code base. So we use things like the code JSON that were not present on the previous slides. Again, it comes from TRC. We use not OK in this case, but we use created, which has 201 HTTP code instead of 200, like OK. And yeah, we can play with all the things that we want to have. If you want to have some Prometheus metrics on top of our server, there is this project that supports HTTP4S natively. I've never tried this myself, because I'll show you in a second other ways how to do this, maybe more properly, maybe in a different way. But I don't know guys who did that, and they use also the OpenTelemetry with that. So they were quite happy about that. Yeah, what if you want to add some custom middleware? So this is actually the implementation of our custom middleware that we use for the authentication and also audit in a few cases. So we exposed few routes like health check, which is get status route to the external world. So anyone could see that, could check whether the service was healthy, Kubernetes in particular. And we hidden some of the routes behind this permission wall that was checking whether the user was able to fetch the resource or not at all. So it's also possible, and this does not require much effort or lots of work. Okay. If you want to implement your custom login, or you want to retrieve user with some cookies, that's possible. There was this I think it's called Crypto 37 library that works with HTTP4S, and it allows you to encode and decode tokens that you can have in your application. So you can return token to the user, or you can receive the header, check whether whether this header contains the cookie that you want to have, that you're looking for. Also decode this and validate the token, and then return the message whether this user is able to be let into the system, or maybe not at all. Course policy, it's pretty configurable. You don't have again to write anything from scratch, which is quite nice. So if you want to allow some other domains to be able to talk to your server, then you can define your methods that you want to let in. You can define the maximum age, or other things like credentials in this case. Okay, if you want to test our server, part of the server logic that should be very tiny regarding any case. We have this connection with the and also integration with the Scala test library that comes very handy. So we can do some unsafe runs in our test code test code to unwrap the values and compare them against what we were expecting. So it's pretty doable, and it also comes with a set of predefined assertions that if you want, it reads like almost like English. Okay. So in the previous slide, you saw tightly coupled logic of the things that are happening in the HTTP layer with HTTP4S. So let's put ourselves in the position where now we want to switch from HTTP4S to, I don't know, back to HTTP or to Zio HTTP, or we want to migrate. I know that some of you and also like some of my friends were sitting on the HTTP for very long time, and all of a sudden they were told that, hey, it's like a technical debt that we actually never resolved, but we need to migrate to new type system or a new library, because they are introducing quite pricey licensing, which is very unfortunate for some of the companies, especially the smaller ones. So if you think about the code that is tightly coupled with which endpoints are tightly coupled with HTTP logic, and with this API layer, you might think, is there actually a way to decouple things? Is there actually a way to extract some parts of the endpoint definitions from what's going on in the server, or like the way how I build a server? Because at the end of the day, if you want to create like a 100 get endpoints, I think you'll have to write lots of boilerplate and lots of repetitive code. So it's not pretty reusable, and we want to do reusable things in software engineering, don't we? And also, there's not a good project to support documentation that we might have out of the HTTP4S. So every time you change the endpoint or you add some parameter to that, you have to edit this YAML file, which is format not readable for humans. It's rather readable for machines and computers. So I come with the rescue because there is a way to decouple things. So we can use declarative API that will either translate this YAML file where we declare our things to our code, which is maybe not the best solution. The second not best solution is the way to translate code to the YAML file. But some people that are way smarter than me, they are these gods from the first slide or the second one, they created few handy libraries. So my favorite one from all of these is Taper. There are also like things like typed API and endpoint for S, which I haven't used, but some people do, and they think it's they are mature enough to be used at the production level. Okay. So actually, why taper? Why should we even bother about this? So again, it's type safety because it uses functional programming. It's declarative, so it separates the definition with the execution. Uh, it has lots of nice integrations. So it also not only integrates with OpenAPI and Swagger, but it also integrates with many HTTP servers, many observability stack, including things like OpenTelemetry, Prometheus, Datadog, and so on. It's a layer of abstraction on top of your endpoints. It's a library, not a framework, so you don't have to leave everything behind and just focus on how I use this. Is it like my new Spring or something, and I have to completely obey to this, or can I actually integrate this with my stack, no matter whether I use HTTP or HTTPS or Zio or any other, or even like Play. Uh, Actually, is maintained, which is from in the open source community. It's actually very important because there is a company behind that, and they respond to your pull requests or to your comments very fast because it's their day-to-day job. All right, so let's have a look at Zapier and what we can do with this. So with Zapier, we can define this base endpoint that we will later on reuse. So here we just define type of the root path and the type of the error that it might return. We can also define other things in the base endpoints, like for example, pagination if we want, or we can add some authorization or authentication, so we can have this like secure base endpoint or things like that. Once we have our base, we can move on to the actual implementation of our endpoints. So so in the first line, there's this definition of the HTTP method. Then we define the second part of the path. We define the JSON body that will handle, that will deserialize, with some example and description that we will later on use with the Open API and so on. Last but not least, we define header, and also we add some description on top of that. Okay. So once we have our endpoint, oh yeah, this is this example with paging. So we can either define this with you know long and integer types, but we also can decode this and make it separate case class that will later on deserialize and map to the actual values. Um, there is no better or worse way of doing that. So you can choose which favor you prefer. Once we have this, we can also define the get with with the pagination option, and also get for a certain user with the concrete ID that will be visible in the path. All right. So we have created our endpoint. What's next? We want to expose them, don't we? All we have to do is to create an interpreter. So depending on what you decide to actually use in your backend service in the HTTP layer, it might be Zio, HTTP4S, or other things that comes with the Zapier integration. You define the server interpreter to create routes out of your endpoint that you defined previously. Once you have this, you can provide this to the server itself, and do the same thing that we used that we did previously. Just run the server. The other nice thing that you can see here with the interpreter is that you can also connect your logic that the given endpoint will be responsible for. So if you want to say, okay, if someone calls this endpoint, it executes this server logic. It calls this repository, or it calls the service, or it says to the database, or whatever. You can also couple this. So you can couple the endpoint definition with the server logic itself, but not with the execution. Okay. More endpoints. If you want to use things like tokens, or you want to use other interpreters, in the previous slide you were able to see HTTP4S interpreter, which some of you might already know, maybe been used. But here we can see that you can also define things like authorization and some token, and also you can provide things like server security logic, which will be again responsible for providing the response, whether this user with this header or with this token is able to talk to our service and send some stuff or receive some stuff from our service. Testing is quite simple as well, because with Scala test and Tapir's type interpreter, we can put our endpoint to this backend. It's IC50 backend with the feature and any, but you can have this with IO and any. And once you have your endpoint definition, then you can test this and actually send this request with our backend stuff, and then see whether this response body contains all the things that we wanted to have. So it's quite simple, and you don't have to add lots of boilerplate to your test, or add things like more mocks, more stubs, and more gluing things together. All right. So I mentioned that in some cases we might have documentation working out of the box with Tapir, and that's true because there is this Open API interpreter that allows you to pass all your endpoints, or in this case it's a single endpoint, and expose this to the external world in terms of the documentation that is updated on a compilation time basis, because whenever you compile things or you change your model, then this documentation then these docs are being updated as well. So whoever is using your documentation, they will see this change immediately as soon as you deploy your service. You can have also Swagger interpreter. You have to do the same. You pass your endpoints to the Swagger interpreter and pass this to the Swagger route, Swagger endpoint to the concrete interpreter that works with your backend. This example is based on Desio, because the nice thing with the Tapir is that you can not only use HTTP4S or your particular type system, but you can move between them. So it's way easier to move from futures to IO, or from IO to ZIO, because it gives you the possibility to, with just a little implementation, it gives you the possibility to create this API layer description without much of the changing when you migrate from one type system to to another one. Just briefly about the entity decoders, we have plenty of them. They have different performance. They, in most cases, you would like to choose CRC or JSON4S if you're working on the on this type level stack. ZioJSON if you work with if you work with Zio, maybe Smithy4S JSON project if you're working with Smithy, and Scala XML if you're working with XML entities. But just briefly focus on this type level CRC. So I guess you know this, but just in terms of the of some thought exercise, the CRC gives you the possibility of functional decoding stuff. So functional decoding your entities that comes with this very handy feature called derivation. So it can derive the concrete decoder or decoder of your case class based on what you've written. If you will not provide that, if you will use other derivation, you actually might face some issues here and there. So this semi-auto is the way to go in most cases. Okay, we talked about the generation briefly. You see in this OpenAPI with Taper example, but there is also this. Async API that you can have in your project if you're working not with Taper but with ACP4S directly. Okay. So what if we want to talk to another service, another ACP service or third-party application that contains some resources that we want to utilize? Here comes the STTP, which is another tool that comes from the Software Mill company. So again, it's functional, it's type safe, maintainable, declarative, and all that. And it gives you this powerful tool of declaring your request that you want to execute from the execution. So here you can see this basic request that defines the method that we will use, defines the URI that we will talk to, defines the content type, defines the token that we will use, and also body that we will search, and also how can we utilize what we will receive from the server that we will eventually talk to. Once you have this, you can provide any backend you want. Again, this is the CATS resource, so it needs to be this backend needs to be released at some point. And once you have your backend defined, you can use this to send this pre-declared request and see what it brings, and whether it brings the value that you were expecting if you were testing this, or whether you're decoding this value in your system logic. What about the observability? We want to have this the Prometheus metrics from time to time, or we want to see how many requests we receive per second, or we want to add some custom interceptors. Is it doable? Is it possible? So yes, it's doable. So you can either use some default metrics that comes with Taper. This is the Gotch, counter, and histogram diagrams that you can have in your /metrics endpoints that you later on can utilize with tools like Kibana or Grafana if you're visualizing your metrics. And also you can add some custom interceptors where you will declare that I want to know how many hits got this particular endpoint, and how many people are calling that within this time frame. So it's all doable, and so we don't have to implement all that yourself. Okay. Another metric, custom metric in this case, just to show you how easy it is to implement those things. So we have a counter that is built from the namespace, some label name, and is being registered to the default collector registry, and then on request we declare and add to counter path method and status, and we increment that. Once we have this, we pass this responses total value to the custom interceptors at the end of the Prometheus metrics. Okay. So coming to the end of this talk, the stack I would recommend, and I've used in many projects, and actually works quite nicely, is as you can follow. So Tapier for the declarative API layer, HTTP4S as the backend execution, CRC for decoding things, HTTP for calling other services or other APIs, Prometheus to expose some metrics, and also Open API with Swagger to create some documentation on top of that. Okay, what about others? We talked briefly. I'm not sure if you can call 45 minutes of a brief talk, but anyway, we talked about some things, but we didn't talk about other ones. GraphQL, we didn't talk about serverless, we didn't talk about performance, we didn't talk about gRPC, and how you can build services on top of that, and we didn't even talk about Smithy, which is another project from these days streaming services that allows you to create declarative API, declarative server, HTTP servers, APIs also, and clients. So there are much more projects that you have just seen on this talk. And I'm really thankful for this, because it means that the Scala ecosystem is actually really rich and ready for things we discussed at the beginning of this talk. So the development of robust and robust microservices with the agile manner of fast feedback loop. So if we were able at Fintium to create software for large banks with that kind of stack, I bet you can do other things with Scala and its ecosystem, and so you don't have to become the category expert, category theory expert at the same time. So yeah, special thanks to you who came today, all the OSS contributors and users, because once this OSS users have this problems that they want to be solved, then the contributors can do this, and they actually know whether they are going in the right direction or not at all. Also, thanks Juan for having me and for making my vacation even better than I could think of, and yeah, Scala Madrid community for being here. So yeah, it's a pleasure to be here. Before we go to the questions, I'll have one request. If you can scan this QR code and give me like a quick feedback. There was actually one question, whether you like the code or not at all, the talk or not at all. It would mean a lot to me. Yeah, any feedback is more than welcome. So I think it takes 20 seconds or something.
And you already use it?
I think I'll need some help with that.
control menu.
Okay. A ver, ¿por qué no? Ay, no, ah,
Así.
All right. So if he,
Okay, so thank you very much.
yeah.
Other question?
I have one question. First of all, thank you for that. That's really useful. I was wondering, because I've never used API in production just for play around and same use case as you're doing here, like you define your code and then you have your docs. So I was wondering if Tapir gives you the functionality all the way around. I have the Swagger or documentation that I want to use in my code.
Yeah. So you want to move from YAML to the code.
Yes, because we're using Smithy for us, and we are defining the API in the Smithy project, then we generate
The client, the code, the Scala code itself. So I think it's not possible to have taper definition out of the code. I've never done this, to be honest. I know that with things like Open SBT plugin, you can generate, for example, from YAML, you can generate the client code that uses HTTP, that uses JSON4S or CRC. But I'm not sure if you can do this. If you can have the taper and some custom server like interpreter, HTTP4S interpreter, for instance, with out of the YAML.
Yes. There is a SVT plugin that basically generates the binaries for creating the clients from a definition of data.
Okay.
I have another question. Well, this was a great talk. The question is, do you have any recommendation? Well, have you ever tried tracing in your tracing, like open telemetry?
Open telemetry, yes.
Have you any recommendation or a good library for using open telemetry in the services?
So we there was this, I think it's called I don't know how it's called, but there was this project, I think it's from Chris Davenport.
I'm working with Chris Davenport in Vanos, and they have the Trasenium that is basically a wrapper of Jaeger. So I was wondering if there is something else.
I haven't seen anything else. Just the project from.
Okay.
And I think it's like the most stable version is 0.24 or something,
Yes.
which is, I guess, it will require some other steps to be like production ready.
Yeah, I mean it's fine because it's just basically a wrapper of Jaeger.
Yeah.
But I was wondering if there was something else. I mean, it's not so difficult to use the Jaeger, the open telemetry production. The ODCs.
Yeah.
I don't know if there's something else beside that.
I don't think so.
Anyway, thanks a lot for the talk.
Thanks for the questions.
Just one question to clarify. Is it fair to say that Tapir is the analog of HTTP DSL of HTTP for Scala?
Depends on how you view this. Yes and no. Yes, and I would say yes, because it gives you the possibility to declare things, but no at the same time because it gives you the decoupling things. So decoupling from the actual server. So how we use Tapir and one of the projects that I was working on. So we did have this HTTP project that it was all the HTTP logic was written with the futures, with the HTTP and so on. So firstly, we did this like in a few steps. So we extracted all the all the endpoint definitions to the separate in the first step to the separate project. where we used Akka interpreter to have like logic correctness. So we just like in the first step we refactored this to have this Akka HTTP plus Tapir. Once we have this, then we actually switch under the hood from Akka HTTP to HTTP4S because we have already these decoupled, and we just provided this Tapir endpoints to this interpreter.
But intention is the same.
Yes.
So it's
Yes.
the same modulo,
Yes.
embedding the coupling into HTTP.
Yes, exactly.
I have another question. So, I mean, we've been talking about these Akka licensing model chains and
Yes.
that stuff. Have you, for example, noticed any change in terms of performance from changing from Akka HTTP to, I don't know, HTTP4S? Or...
No, we didn't have any performance issues. I know that if you measure your performance with the API layer, actually the thing that we didn't know much about is that actually your entity deserializer is quite important in this case. So whether if you're using I think it's called like Circe is one of the possibilities. The other one is called JSONiter, which also does provide quite good benchmark for this. So we haven't seen any issues regarding performance, but we also don't like serve more than couple thousand requests per second. So it's still fine, but I guess in some cases it might be a bit more critical, and the volume might be a bit higher. Thanks for the question.
Okay. More questions? Okay, just before we finish, there is some people here from Civia functional that they would like to say something about the Scala days, I guess. So please. Sorry? Yeah. Hello.
So, Holidays is back, and it's in Madrid this year. So, yeah. The call for papers is closed, so I'm sorry if you missed that. But how many of our team put paper in? I mean,
Yes.
Okay, good. So you might see Ignacio there. But yeah, so yeah, there we go. Thank you. So we've got, obviously, you're welcome to come to Seattle as well. But Madrid is going to happen in September. So mark the date. The early bird tickets are coming out pretty soon. I'm not sure when, but yeah, keep an eye out. We can send a message through the group. That'd be great. Thank you. Yeah. So yeah, it'd be lovely to see you there. And yeah, thank you.
Thank you very much. So, cuidado que viajan. Avisas y esas cosas, ¿no?
Todavía no ha llegado, pero sí.
Pues cerveza.
La cerveza sí.
Pues nada.